Hello, everyone, and welcome to another Jakarta Tech Talk. Joining us today, we have Alex Shovik to discuss Jakarta RPC. Alex is an architect at Oracle, where he works on Oracle Coherence, a leading in-memory data grid product. If you have any questions for Alex as we move through today's presentation, feel free to ask it in the chat or using the tab at the bottom. So without any further delay, Alex, over to you.
All right, thank you, Haley. All right, so as Haley said, I work with Oracle. I'm an architect on the Coherence team, and I'm here to talk about a new proposal for Jakarta GRPC. And just to give you some background, a brief history, how we came to this point. I mean, back in 2011, we were looking for a way to implement native clients across multiple platforms for coherence, and we had our own technology that we wrote years ago, but in the meantime, a lot of things have happened, and so we started looking at what frameworks are out there to make remote calls from different platforms available. And GRPC obviously came to the forefront. So we started working on the implementation. We did the initial implementation of our server and started working on some clients back in 2017, 2018. And in the process, we realized that what we've built actually is more than we need. It's something that really makes more sense within the application framework, within the Java EE spec or something like that. But at the time, what we decided to do is to contribute to Helidon. Helidon was recently released, and we talked to people on the Helidon team and decided it made sense to move our implementation to Helidon. And we rewrote it pretty much completely in the process to make it look more like JAX-RS, which is what Helidon uses for web services, for REST services. So we tried to do something similar for gRPC. And then about a month ago, we actually said that even Helidon, as it is not really a proper home for it. This thing is more general than that. We really should propose it as a spec, and whether we propose it as microprofile spec, as Helidon is microprofile implementation, or propose it as Jakarta spec. And we actually decided to propose it as Jakarta spec because, as I said, it's very similar in how it looks, how it feels, and its purpose to JAX-RS except when you're writing gRPC services instead of REST services. So I have a link here to the proposal where you can find more information about what we are proposing, but I guess I'll walk you through most of this stuff anyway. So, because the first question whenever I see a new proposal, I want to know why. I mean, what is it intended to solve? And there are actually a number of goals we wanted to fulfill. So we wanted to make gRPC services easier to implement. We also wanted to make clients easier to implement, which we saw as we were working with gRPC, we realized it was a big pain point, and there is a lot of boilerplate that you need to do in order to implement both services and clients, but mostly clients. We also saw that there's the integration between gRPC Java implementation and things like Jakarta EE specs and Eclipse microprofile specs is not quite where we want it to be. We wanted to use things like CDI, et cetera. And kind of gRPC Java out of the box makes it a bit difficult, which I'll get to in a minute. We also wanted to have better support for modern Java to be able to modularize applications, which is also a bit tricky. And finally, from our perspective, because we have our own serialization formats, and customers can choose their own serialization formats to use with coherence, et cetera, we wanted to make sure we support marshalling of payload in any format. So gRPC as it is somewhat format agnostic, but it's very much the tooling and documentation, everything is geared towards ProtoBuf, and we couldn't afford to use only ProtoBuf. I mean, we are fine supporting ProtoBuf, but we need to be able to support other formats as well. So before I go any further, I mean, this is not a knockoff on gRPC Java. gRPC Java is awesome. I mean, we like it. We've been using it for the last 4 years since version 1.5, 1.6 or something like that. And the goal of the spec is not to replace gRPC Java in any way. It really is to make its usage easier and to make it more seamless for the Jakarta EE developer or Eclipse microprofile developer to write gRPC services and clients. So let's go and let's go into it a bit deeper and talk about how we propose to do this. So the first thing we wanted to do is to make services easier to implement. So we can understand what the difference is. Let's look at how you implement gRPC services the standard way if you're just using plain gRPC Java. So the first thing you need to do, you need to define your messages in a proto file, and it's fairly straightforward, but it is a work that we don't think is always necessary. So you define messages that are going to be passed over the wire, and then gRPC Java will generate classes for these messages that you can use within your application. Then you define a service interface, which looks something like this. You define a service, give it a name, put it in a package, and then you define a number of RPC methods that are either unary, which means they take one request and return one response, or they're server streaming, which means that they return a stream of responses. They can also be client streaming, which means that they send multiple requests to the server and then expect one response back. Or they can be bidirectional, which means that they effectively have a pipe open between the client and the server, and both the server and the client can send messages to one another at any point in time. So once you do all that, you need to configure Maven plugin to generate service stub. And then you need to implement the service. And the way you implement the service is by extending a stub generated based on the proto file we saw earlier by the Maven plugin we just saw configured. And then you override the methods. Basically, the stub that gRPC generates only has methods that throw unimplemented operation exception, right? So you go ahead and you basically override every single method defining that service interface, and you do your implementation. And the way gRPC methods are implemented, you basically have your parameter. There's always one argument that you get as a argument, as a method call argument, and you can send one or more responses back depending on whether the method is unary, server streaming, or whatnot, right? So even when you're sending single value back, the way you send it, as is the case in this example, the way you send it is by using stream observers. So gRPC assumes that there could always be more values, right? So it gives you this reactive API, which they call stream observers. So you can send one or more objects. So you can call on next with the payload on next. You can call it multiple times, and then once you're done sending all the responses, then you can just call on completed and mark request as completed. And obviously, if there is an error, then you need to call observer on error to notify the client that an exception happened, right? So that's effectively, I mean, as you can see, there is a lot of boilerplate here, right? There is one line, which is task equals our API, our service, create task with some description. And then everything else is really gRPC infrastructure, the try catch block, all the calls to observer, et cetera, et cetera. So how does that look like with Jakarta GRPC? Well, you only have that one line, right? So we have a set of annotations that tell us what the service is. So because we don't have proto file in this case, we have gRPC annotation that gives service a name, which is fully qualified package and service name. We also, in this case, configure a marshaller. We want to use JSON as a payload. And we configure this as CDI bin by doing applications code to the class level and then injecting our dependency inside of the service. And then the method itself, really, I mean, you will see big difference here is that we don't take stream observer as an argument anymore. We could, that format is still supported, but we simply mark method as unary, we return the value that we want to return, and then the framework under the hood does all the gRPC specific stuff and sends this task that we are returning back to the client. It calls on complete, or if case there is an exception, when this method is executed, it calls on error and passes that exception back. So obviously this is not exactly the same as the service we just saw, because this one uses ProtoBuf, so it uses task message, not task, and we have to do some wrapping. So we get a task from our service implementation, from our API, and then we have to wrap it, convert it into a task message, which is a ProtoBuf class, that the ProtoBuf generated class that we want to send back, because that's what API expects. So in this case, because we're using JSON, we don't have messages. We can just use our standard Java POJOs as both or native Java types like string. We don't take string value, which is a ProtoBuf type, as an argument. We take string, and we don't return task message, we return task, right? So it makes it, when you're not working with ProtoBuf, it makes it much easier to implement services, because you can just reuse classes that you already have, and you don't have to generate pretty much anything. Now, if you want to implement the same exact service as we saw, then it's a little bit different, right? We don't, we specify the name that the GRPC clients generated from that ProtoBuf file will expect. So, we put service in the appropriate package and give it the right name. And then we implement method exactly the same way, except now we use ProtoBuf types as arguments and return values, and we still need to, because our API internally, our implementation uses our domain model. We need to convert our domain model into ProtoBuf message. But other than that, the implementation is exactly the same. I mean, the only thing that changes really are these arguments and return values. So that's pretty much it on the server. And there is, obviously, I mean, in this case, we're looking at unary method, but we support other method types. So you can also annotate your methods with server streaming if you want to return multiple values. And we also have some return value optimizations for that. So if you return Java util stream of values back in mark method as server streaming, then we'll effectively just take that stream and read values from it and stream them back one by one and complete once the stream is exhausted. So the next step is, how do we make clients easier to implement? And going back, this seems a bit repetitive. So, with GRPC Java, when you're implementing clients, you still take that ProtoBuf file. So you probably still have the file. So you define your messages, you define your interface. Now, the interface can be the same, but it doesn't have to be the same, right? So, it may be the same artifact that you already have from the server, or it may be a subset of it, right? Because you could have a service that is, for example, just read-only service and only cares about these four methods, right? So there is no reason for you to take the full ProtoBuf file and tie yourself to the full API on the client, because the more things change on the server, the more chances there are that you're going to be broken, right? So, if something changes in incompatible ways. But so you could generate a client interface, a client stubs that only have methods that you care about, and you probably should. But that means that you actually have to maintain multiple proto files for different things. You may need some messages on the server, but not on the client, et cetera, et cetera. So you end up having multiple artifacts to manage. And then you, again, need to configure Maven plugin, which is fairly straightforward, but just a step. And then you need to initialize. Now when you're using this, the gRPC will generate client stubs for you. And there are actually 3 different client stubs. There is blocking stub, there is non-blocking stub, and there is future-based stub. The problem, though, is if you want to get access to the full gRPC API of your service, you actually have to use the native gRPC stub that uses stream observer, the non-blocking one, right? Because both the future-based stub and the blocking stub are actually very limited in the type of methods they support. I believe blocking only supports unary methods, and future may support server streaming, but I don't think it supports client streaming and bidirectional. So in the end, if you want to use full gRPC API, you have to use blocking. You have to use non-blocking stub that uses stream observers. And in order to do that, first you need to create a channel, right? In order to create a stub, you need to configure a channel. So in this example, I'm just creating a very simple channel that connects to gRPC server on localhost port 1408. And then the next step is to actually implement your client that wraps the stub that you're using. Because the stub is very much defined in terms of proto-generated classes, such as task message in this case, and our application works with something that's in our domain model to need the conversion here. And again, if we want to do a blocking client API, as is the case here, we basically need to figure out a way to block, right? So one way to do that is to create completable future, and then we call our method on the stub, pass it stream observer, and that stream observer effectively completes the future either successfully or exceptionally, depending on whether error happens or not. And then in the end, we simply block, waiting for that future to be completed one way or another, right? So again, there is a lot of boilerplate here. Pretty much all of this is boilerplate, right? Because all we're doing is calling a method on the stub that we know exists, that has effectively the same signature as the method that we defined at the very top, that we're calling this within, and everything else is just gRPC infrastructure code. So all of that can actually be simplified, and that's kind of what we do. Right? We took the same approach that Eclipse microprofile REST client did. So you effectively define an interface on the client, and you define the methods on that interface, and the arguments and the return values and all of that stuff, right? And this should match the server, right? And the method names will be used to match gRPC method names. The service name from the gRPC annotation will be used to find the service on the server. Again, you have the ability to configure marshaller that will decide how the payload, both return values and both the requests and responses are serialized. And that's pretty much it. Once you do that, and again, if you want to define smaller interface, you just define a smaller interface. Just omit the methods you don't need. But there is no proto file to deal with in this case. It's just Java interface, really. And if we're looking, I mean, obviously this is JSON interface again. And if you want to see the proto interface, it's exactly the same. I mean, in this case, we're just saying gRPC marshaller is ProtoBuf, and we're returning task message and taking string value and boolean value ProtoBuf types as arguments instead of Java native string and our domain task class. So once we do that, all we need to do is inject gRPC proxy where we want to use it. So in this case, we have our application code, we have task manager, and we simply inject gRPC proxy with the interface we defined earlier. Right? So we have our to-do list gRPC client interface, we inject proxy for it, and we can call methods on it, right? So in this case, we're using ProtoBuf proxy, so we're going to get we're going to take string, convert it to string value, and pass it to the underlying service. And in this case, we're using JSON proxy, so we just take string and pass it directly as is. So the next thing, as I said, that we wanted to address is better integration between gRPC and Jakarta and Eclipse microprofile specs. And the first thing that we looked at was CDI support. And on the surface, it looks like it would be fairly simple. And gRPC provides the base class, you do your implementation that extends it, you mark it with application scope, you inject something into it, and you just use it like any other CDI bean. Unfortunately, if you ever try to do that, you know that you will run into this. The problem is that the base class is generated by ProtoBuf compiler based on the RPC service definition actually has this bind service method, which is final, and CDI refuses to proxy it. So unfortunately, I mean, there are workarounds, and this is something that I've done, for example. So you can create actually manage bean that I typically put it as an inner class within the service class itself, and just call it manage service, which simply delegates bind service method. It doesn't make it final, and wraps the service itself. Now notice that it doesn't need to delegate anything else, right? I mean, we use constructor injection in this case, so we can construct the actual ProtoBuf generated, or well, our implementation that extends ProtoBuf generated class. We can fully configure it via constructor within this beans constructor, and then we don't really need to delegate any other methods because they're never really called. I mean, the way gRPC works under the hood, every method has its own definition, and it's really that method's definition that determines what the method is called on. In this case, because the bind service of the actual service implementation itself, the one that is final in the generated class, that's what actually determines what the method is going to be called on. So this is just a way for us to get dependency injection to work. It's just a workaround. But we don't like workarounds. We want to make it simple. So Jakarta GRPC really CDI support is not only there from the beginning, it's kind of required. That's how we discover services and register them with the server, etc. Right? So we'll look for any bean that has FGRPC annotation when we are starting up, and we'll register it with the server. So this is it, really. I mean, we saw the example earlier. It's there. It works out of the box. There is really nothing special that we need to do to make CDI work. The second area we wanted to improve is configuration. So obviously, in GRPC, Java is powerful, but it's fairly low level. So you need to create channels, you need to define hosts and ports, you need to configure TLS, etc. Programmatically. So we wanted to provide, Skeleton is micro-profile framework. We wanted to make sure we want to use micro-profile config to configure both the client and the server. So you can do something like this, right? You can define your gRPC channel, you can define server, host, port, even TLS information. We'll see an example later. And then you can simply annotate your client with a channel, or even better. I mean, well, depends what's better. I mean, it gives you more flexibility. So if all you need is to connect to a single server, then annotating client interface with a gRPC channel is the way to go. But if you want different injection points to connect to different servers using the same client interface, then you can actually annotate injection point to gRPC channel, and it will determine which server to connect to. The next thing is better support for modern Java. And what we primarily mean by this, better support for Java module system. And this is kind of a long-standing issue. I opened this issue back in, well, you can see it on the screen, back in September of 2017. And unfortunately, this screenshot was taken like a couple of days ago when I was working on this presentation. So this issue is still open and has had quite a bit of activity and comments on it, and a lot of people asking for the gRPC Java team to fix it. And you can see things like this and things like this, etc., etc. But ultimately, it's a hard issue for them to solve, because the issue is effectively a split package in some of the modules that they have. And there is no non-breaking way to fix that. And they still have to worry about Android usage and requirements for gRPC Java to be used on Android devices and whatnot, so that they have to support older versions of Java as well. And it's been a difficult one to solve, and that's why it's still open more than 4 years later. Now, we did solve it in Helidon when we were working on this, because Helidon at some point moved to Java 11 plus only in version 2.0, and we basically had to repackage gRPC in a way that that eliminates the split package issue. So our implementation, I mean, this is not necessarily part of the spec, even though spec should ensure that whatever implementation supports it works properly within the Java module system. So it works with Java 11, Java 17, and future versions of Java. But it is a solvable issue, as long as you repackage gRPC Java yourself. So that's basically what we did, and it's been working fine for us since 2019, basically. And then last but not least, as I said earlier, one thing that we wanted to make sure we can do is support payload marshalling using different formats, right? So, ProtoBuf is fine, but it does require you to kind of translate between ProtoBuf, because everything that's generated from ProtoBuf is final. You cannot add methods to it. You cannot really extend those classes. If you want to do anything, you really have to, you really can only treat those classes as messages, that's what they were designed to do. So, you have to take them on both ends on the wire and kind of unwrap them and convert them into something that your application can actually work with. So, and that's fine, but it's not always ideal. And as I said, we wanted to make sure that payloads can be supported with other formats. Like if you're working with with Kafka, you probably want to support Avro, and if you don't have to do conversion from one format to another, you can optimize things to make them more efficient. Like if you're using coherence, you're probably using POF. If you're using Mongo, you're using JSON or BSON, or same thing with Oracle JSON database. I mean, you're going to be, your application is going to be using a certain format, and if you don't support that format in the wire between those services, then you have some additional work to do to unwrap those messages and convert them from one format to another. So when we started looking into this initially, we realized that marshalling of any format in gRPC is actually supported, maybe too well. Basically, every method, every gRPC method that you define allows you to configure both the request and the response marshaller. So you could technically have every method in a service use different marshaller for the incoming payload for the request and for the outgoing payload for the response. Right? So there is no reason you cannot have one method come in a JSON format, return ProtoBuf, another one comes ProtoBuf, you return POF, etc., etc. So you can really do whatever you want. The problem is practically this is really not exposed because documentation on how to do it is pretty much non-existent. I mean, other than Java docs and reading through source code and figuring out how to do it. And the tooling, as we saw earlier, pretty much depends on and only supports ProtoBuf. You're kind of expected to write those proto files with messages and RPC service definitions and generate code from them and start there, right? Go from there. So we wanted to make the underlying features that gRPC already has more exposed. So what we came up with is basically allow you to have named marshallers, and on any service you define which marshaller you want to use. By default, we'll use ProtoBuf because that's kind of historical default for gRPC services. So if you don't specify anything, we'll assume it's Proto and we'll use ProtoBuf marshaller. But you could override it. You could say that you want to use JSON for this service, or you can use POF, or you can use even Java serialization, although we kind of deprecated that because of security issues and whatnot. But whatever format you want, you can actually write marshaller for it, register it, and use it. So any marshaller is supported the same way. ProtoBuf is the default. So if you don't specify marshaller, we'll try to use ProtoBuf as a default. At the moment, as I said, you configure marshaller for the service. So it's not at the request response level. We could easily support method level overrides. So I don't think we do at the moment, but we easily could. I'm just not sure how useful it is. Typically, you have a format that you want to use and kind of use it throughout, use it for all the methods on the service. But it's a feature we could easily add. And implementing new marshallers is fairly straightforward. So in this example, I'm configuring JSON marshaller. This is, for the most part, there's some bits that are missing here, but for the most part, this is the implementation of the JSON marshaller. And so there's really nothing to it. I mean, you need to be able to, this uses JSON-B to serialize object to JSON, returns open stream, returns input stream with the generated JSON payload, and then same thing on the other way around. When we get JSON payload, we parse JSON from that input stream into a class of a given type. Now, because we need to know the type for some of these things, fortunately, marshaller is defined at the method level. So even when we use JSON, we can configure multiple JSON marshallers for different types, right? And in order to do that, we have what we call marshaller supplier. So this is actually what allows us to create marshallers. So if you say that your service should use JSON marshaller, we find a supplier that's named JSON, and we use it to get the new JSON marshaller for a given type. So that's really what makes this whole thing work. All right, so that kind of concludes the intro part. So let's look at a demo here. So I have, because again, all of this stuff already exists. We're proposing it as a spec, but I'm using Helidon implementation of what we are effectively proposing to demonstrate everything. So on the server, I have 4 different service implementations. I have my raw GRPC Java ProtoBuf based implementation. So you can see that I extend generated class. I have my services proto file here with both messages and service interface, right? So I extend generated class, which can be found here. And I override the method. So I have my constructor that injects my service API. I have my helper that converts task that my API returns or takes as an argument into a task message. And then we have methods implemented, right? So we have create task, which is the method we saw on the slide, and then we have get all task, which again is very similar. So we make call to our API, we call observer on completed here in this case because we are actually streaming tasks back. We call get all task, we map every task returned to task message, and then we call observer on next, and then after we stream everything back to the client, then we call on completed, right? Same thing with get task, except it takes completion as an argument, find task, delete task, right? But as you can see, it's very, very, like every method is very similar. You have your try catch block, you're calling observer on next, on completed, on error, etc. Right? So that's our plain gRPC implementation. At the bottom, I have the workaround I mentioned earlier. In order for our server to discover this service and to register it, we have this CDI bean that allows us to inject API and repository implementations and then configures the actual service with it. Right? So if you look at it all together, like if not counting workaround class, we have about 220 lines of code, most of it boilerplate. We have the exact same service written using Jakarta GRPC, Payload GRPC, and proposed Jakarta GRPC specs. So we're putting it in a different namespace because we're going to run all four of these services on the same server. So we need to put them in a different namespace. We don't specify the marshaller, so it will use proto by default. But in this case, we don't need any workarounds, right? We're also configuring interceptors. I'll get into that a bit later. So we want to use logging interceptor to see when the calls are actually made on this service on the server. And we still need to do the wrapping and unwrapping of a task conversion into task message. But now our methods are much simpler, right? We simply have unary method, and then we call API create task and convert that to task message. Get all tasks simply does. So, the only thing that's left is the actual code that does any work. Right? So we have server streaming methods, etc., etc. So altogether, this saves us about 100 lines of code or so. So this is really the whole implementation of our gRPC service. And these implementations are fully compatible. There is nothing different. If I rename this service and basically run it to the same endpoint that the raw plain gRPC Java client expects, it will behave exactly the same as the one that was created based on the generated class, right? And then we have the same implementation, but using JSON. In this case, you can see that we configure gRPC marshaller JSON. We, again, inject our dependencies. We have the methods that look exactly the same. Now, the difference here is now we are just using our regular Java beans. We don't have any generated message classes. We don't have anything. We're just using plain POJOs. And if you look at task, it's just ignore the portable type. That's actually POF support, which I'm going to get to in a minute. But this is basically just a regular Java POJO that we are using. Right, and then the fourth service implementation, and again, this service is the same as the JSON one. It's only 100 lines of code. And in this case, actually, we do have, and this is something to point out, we do have a couple methods here that actually take message, because again, gRPC, right, I wouldn't call it limitation exactly, it's just the way it works. You have single request coming in, so you cannot have multiple arguments. So in this case, we need to pass the ID of a task to update and the value to update within that task, right? So we need to wrap them some way using this update description request, which is basically just ID and description. In this case, these messages are just regular Java static classes with public properties. Could eventually, I mean, what I'm really hoping, this is all using Java 11 still, but this really should be Java records if you're using Java 17 or higher. So, so that's the JSON implementation of the service, and then we have the same thing but uses coherent portable object format as a serialization format, which is, again, it's a binary format that we recommend clients use if they're using coherence. So if we get messages in POF format, we can actually do things more optimally. If your backend is coherence, we can just pass them through in any case, and that's actually what coherence GRPC service for the native clients does. So it's very similar to the JSON one. The only difference really is that marshaller is different. Everything else implementation-wise is the same. And then the messages are slightly different because they have annotations that will allow us to generate serialization code for POF from them. So that's it. And then on the client, we actually have 4 different clients. We have the plain GRPC proto client, which has a client that's a wrapper around generated stub. So you can see the code that I showed earlier on the slide here. We create a channel that connects to localhost 1408, which is where I'm going to be running the service on, or GRPC server on. We have a method now that does conversion the other way from task message to task. And then we have a bunch of wrappers around the stub that call the stub and then complete the future with the result, and then we block on that future. So pretty much every single method here is implemented that way. So you can see how this gets a bit cumbersome, and we have almost 300 lines of code here. And if you look at the same thing for our Payload proto client, let's look at that one because that's exactly the same. All we have is this, right? So in this case, we explicitly configure the marshaller to proto, which is something you can do. Configure the service to the proto service we have on the back end, and then we have methods that we wanna be able to call. Right. So that's all there is to it. And then within our task manager, we simply inject GRPC proxy. So without going, I mean, the other 2 clients, JSON client, POF client, they look effectively the same as this proto client. I mean, the only difference really is that they use task and string and boolean instead of task message and string value and boolean value, bool value from ProtoBuf, right? So they just have different marshaller configured, and obviously request messages that they need to send to the server. So let's see how all of this works. Let's start the server. This is always so much slower when I'm presenting them, and I'm not. All right, so there's something I want to show here. So you can see that we print in the logs that GRPC server started and it registered number of services. So we have our examples proto to-do list with these methods. This is actually the native gRPC Java service. Then we have our POF service, which is Jakarta GRPC service. We have JSON service, and we have, oh, actually, sorry. So this is proto service that uses Jakarta GRPC, and this is proto service that's generated from the ProtoBuf file. Right. And then we also have, because we are running coherence inside of this process as well, we have coherence name cache service was discovered as well. That we're not going to be using. So I'm going to start first client. Let's start the Payload proto client first. So the client is really, I mean, I showed you the actual class that interacts with the gRPC server, but the client is actually just a JavaFX application that connects to this server, and then it can create tasks, complete tasks. Okay, so, and I want to show you here, because this is a proper Jakarta gRPC client. We should actually see that logging Interceptor should print out calls. And you can see that it did. Like right here, you can see that when this application started, it registered for events to receive from the server, and it called get all task. And this was server streaming method and marshaller that we use, this message marshaller, which is ProtoBuf message marshaller. So we can create some tasks here. Right, we can complete tasks, we can clear completed, etc. And as I'm doing that, you can see the calls are being made to the examples proto to this service, right? So now I can also start the gRPC proto client, which is going to be talking to a different gRPC service. But in this case, you'll notice that when I make the calls, I mean, everything should still be reflected, because now both clients are actually listening for events coming from the server. You can see that this client already has the state, and just to give you an idea. So I'm going to go into server, and let's bring both clients on the screen. So now I have Payload client, Jakarta GRPC client on the left-hand side, and then gRPC Java client on the right-hand side. So, because this one is not a proper Jakarta gRPC service, we don't have a way to configure interceptors the same way, so there's actually no interceptor here. So I can create tasks. And you can see that task is created, but nothing is being printed out on the server because different service is being hit, and we are not getting. But if I use this one, then again, you see that sync between both works, both receiving events. In this case, this got called. And obviously, we can start POF client, and we can start JSON client. So now we have see on the server that these clients are being started. They already made the calls to I was going just these two in this case. So now we have the same clients that we saw earlier, but this one is using JSON. And this one is using POF. And again, anything I do is reflected in any of them. I can bring the other two clients screen. And you can see that if they're completed, it's reflected everywhere. So they're all talking to the same server. They're all using the same backend data store, but they're actually using different payloads, different service endpoints, different service implementations on the backend. Very similar service implementation, but actually different instances of the service, different instances of the methods with different marshallers. So that's it for the demo. So let's go back to the slide and cover. We have a couple more minutes. So I want to talk about some additional considerations, because you saw, like, everything I've shown so far uses blocking clients and servers, so everything is synchronous. But Jakarta GRPC, absolutely. I mean, GRPC itself under the hood, like server is always non-blocking, and then clients can be either blocking or non-blocking. But effectively, as I said earlier, the only stub that allows you to access full power of gRPC is the non-blocking one. So everything is non-blocking under the hood. So we wanted to expose that as well. So in order to do that, what you need to do is really just change this, which is the example of our blocking client, to this, right? So there really, if you look at it carefully, there are really only two changes here. The return type changes from task to completion stage task or completable future task. And then the return value changes from future join to future itself. So in this case, we're just going to create a future, submit the request, and then return that future. And then eventually the future is going to get completed. So this allows you to basically use completable future API. So you can say in the caller of this method, you can say when completed or handle or whatever you want to do. You just use full power of the completable future. And you can do the same thing on the client, right? So you can go from this to this, right? And you'll notice that it only changes for unary methods, because the methods that like get all tasks, I didn't actually cover this earlier, but I should have. So this is the optimization that I said we have, right? So if you return stream of something from a server streaming method, then it will just send all those values back one by one and then complete when the stream is exhausted. So those are already non-blocking, right? I mean, they'll just send stream values back. But the unary ones that used to be blocking are now non-blocking as well. So you're going to call the method, you'll get your completion stage back, and you can call when completed, you can join on it, you can do whatever you want to do. And then on the server side, same thing. So this is your blocking service, and this is your non-blocking service. Now, in order to implement non-blocking service, there is an assumption that you have some kind of non-blocking API that you use to typically access your data store. So whether you use reactive database API or you use something else, like you use reactive Mongo API or reactive async coherence API, any of those things will allow you to do this. But basically, you need a backend that allows you to do things in a non-blocking way. If you don't have that, then it becomes a little bit tricky, and using just exposing this as plain blocking services and letting us worry about unblocking when necessary is probably the easiest way to go. So another thing that I briefly touched on, and we saw it kind of working on in the server demo, is interceptors, right? gRPC allows you to define both server and client-side interceptors. It can modify the request, modify the response, add security information to it, et cetera, et cetera. So in order to use those, you basically have a couple ways. You can define interceptor bindings. In this case, we're saying, okay, this is logged annotation, and we're marking it as gRPC interceptor binding. And then we create our interceptor and we apply that binding to it, right? So we say, okay, so when anything is annotated with log, then this is the interceptor you should use, right? And this is just, again, CDI being marked with gRPC interceptor and logged interceptor binding. So the actual implementation is just at this point gRPC IO gRPC server interceptor, right? So it just prints out the call information. And then when you define the application, you can simply annotate your service with log, or you can annotate individual methods with this annotation, and that the interceptor will be applied. If you annotate service, the interceptor will be applied to all the methods. If you annotate methods, the interceptor will be applied only to a specific method. You can also just, you can also not create interceptor bindings and just specify interceptors explicitly. So if you have interceptor classes, they don't even have to be, I think, I'm not sure, CDI beans at this point. I mean, you can just list them in a gRPC interceptors list, and they will be configured for the methods and the service. And the same thing with clients, right? I mean, exact same thing, except your Interceptor implementation. In this case, implements client Interceptor, which is slightly different interface from the service Interceptor. And finally, last but not least, I guess, security. So as I said earlier, we do have support for configuration, and that extends not only to what the host and port is, but also to TLS configurations. So you can specify whether TLS is enabled, what are the certificates and key file paths. In a Kubernetes deployment, for example, these can be read from Kubernetes secrets, and the server can be configured that way. And then we also plan to support, this is not supported at the moment, but by the time final spec is out, we plan to support JSR 250 security annotations, just like most frameworks do in JAX-RS. So you can define who has access to what endpoint by specifying roles allowed, permit all, deny all, etc. So that, I believe, concludes everything I had. You can get a source for the demo I just showed from this link. So all the clients and the server implementation are there. There's one client missing here, so I guess I took this screenshot earlier. There is Helidon GRPC client, Helidon Proto client missing. But all 4 clients and the server are there. You can run the example yourself. You can review the code. If you have any questions, you can reach out to me on Twitter, on Slack. I'm not sure what's the best way to reach out. But yeah, Twitter's probably good. And with that, I will open it to any questions. Thank you.
Thank you, Alex, for that presentation. I'll just remind everyone in the audience, if you do have any questions, you can throw them in the Ask a Questions tab at the bottom or the chat. And in the meantime, I'll just go through a few things here. So we are looking to book more Jakarta Tech Talks into 2022. So if you're interested in presenting, you can feel free to fill out the form, which I will link in the chat. And as well, if you haven't already done so, we encourage you to register for the Jakarta One live stream December 7th. It's our largest Jakarta event of the year, and you won't want to miss it. So you can also register for that with the link I'm putting in the chat now. So you should have both of those. Let me just go back here. I don't see any questions. So if that's it, then I'd just like to thank you again, Alex, for the presentation today. I hope everyone has a wonderful afternoon.
Thank you all. Bye.
Thank you. Bye.